You're going to mute that. Without that, nothing will work. That's a miracle. And then,
It's not on.
just warm it up.
Is it warm yet?
I thought so. Yeah, there we are. Beautifully on my own display of this slide, it says interface to network security foo. And then on the next line, it says unctions. I'm Adrian. Linda is Linda. This is I2NSF. We have a full agenda. The blue sheets have been round once, but I'll push them around a second time so you can fill in if you're missing. And one thing to add, that if all things go well, this is my last session chairing you. I'd like to say it's been a joy. Hopefully you'll be successful going forward without me. Oh, we have an AD. We can definitely, now we can do real work.
Thank you very much. Let's get started. Okay. First of all, is the notes well? So hopefully everybody will read it well. This is the new version so please read it. Here is some trivia. So charter, I think I don't have to repeat that. Mailing list for newcomers. And we have minute taker, Frank and Sue. Thank you very, very much. And for everybody else, since we have Etherpad right there, there's a link from the IETF99 agenda. Please just go there, add your comments or name, especially when people can now record your name correctly. And if they mistaken your notes, then please correct that online so we can all contribute to the minutes. And blue sheet. Okay. So here's agenda being posted, and here we're going to get started. Wow. So here's agenda bashing. And if there are any questions, anything with agenda changing, if not, we'll just go as this plan. Okay. So congratulations to the problem statement and use case document authors. We finally get one RFC. Thank you. And the second one to be out is the framework. We have completed the working group last call, and going to be sent to IESG for review. So there are two other working group documents. The working group have decided to leave them current in the working group until the working group charter either close or recharter. So we'll leave them open as we move forward. That's the terminology and the gap analysis. So there's another working group document on the client interface requirement. And we're going to decide if we want to move that forward to the working group last call. So here are four or five drafts ready for working group adoption. We can discuss that further on the mailing list. They're primarily information models and data models. And we have quite a few contributions on the information models and data models. And so initially there was some inconsistency among them. This morning, thanks to all the authors, we got together. We had a really productive discussion in the morning. aligned the models and decided on the relationship among all the information model drafts and data model drafts. Later on, Sue Harris is going to talk about those relationships and how we move forward with all those drafts. So actually, that's my portion. And Sue, do you mind come here to talk about this morning's discussion, give people an update?
And just to remind people that as a working group, we looked at whether or not to have information models and made a decision that they were going to be useful for us. That is a decision we could revisit if we want to, but where we are at the moment is let's push forward and have information models to drive our data models.
And so based on that, let me give you a few discussions. We had a model discussion with some of the authors. Please go ahead. So first, I'm going to give some high-level goals or ideas. First of all, information models we treated as blueprints for data models, okay? And there are two types of alignment, exact or a subset. And we also worked on this based on which is your core concept or which is your key model. And then you group your models around the core concept. And we want it to be easy to understand so that, just a minute, we can provide models which can go to vendors and people who are trying it in academia, like our hackathon presentation, which is next with Paul Jean. We want easy to understand models. That's why Yang was written as it is. Go ahead to the next one. So let me talk first about why blueprints are the basis for complex structures. As you see, we're in Prague, and this is one of the largest structures. But when people build a building like this, they start with a portion of the building, and then they build up the structure. And the same is true of an information model. We may use we were treating the information model like a blueprint for this large building. It's got a lot of structure, but maybe we only do so much in the data model. Some working groups that are doing Yang models think that the information model should be exact. There are pros and cons. That's just the way we were sort of talking about how our capability models and our capability model, our customer-facing model, our NSF-facing model. So I'm just providing some thoughts that we had from the authors. Go ahead. Then it's very important you verify the blueprint, because if you don't, like this building doesn't work so well together, maybe you have a floor sitting out. So if you have the data model equal the information model, then you can check the data model out with tools. If you do like we do, we're suggesting, and you do the information model as a future blueprint, which will guide you in your data models, you must actually take a different approach. There is a downside if you use the case where you have the data model equal the information model and you trust in checking it. You go all the way down to the data model with lots of work before you actually check it, and you may have a large cost like this building that's not quite aligned. So that's why we thought, okay, we're going to use the information like a blueprint, but we have to carefully hand check that all the information models work together. This is just one approach. As I said, you can use the information model equals a data model and then trust after you've got all the way through that the data model checkers will work, or you can do what we're suggesting, which is to hand check, synchronize, look at the information models, use them as a blueprint, and implement subsets. That's how people build large buildings, and we thought that might work. Go ahead. So that's the recommendation. Verify the complete information model. That means if you have 5 information models, you must verify them by hand and then build a portion of the model in stages, simple then more complex. That's the approach our teams and development teams have been taking. Will the team from Korea, all the people who were here at the hackathon stand up and be recognized at this point for their work on the hackathon code? Come on, guys. Especially the students.
Yep.
So we also have people who are working on product code. We think that with simple, more complex, we get an understanding. Now, this is possible because of the good work to base everything on the key model of capabilities. Go ahead, Linda. Capabilities is like our key structure that you may see in Prague of the cathedral and some of the castle here, that around which was built all the family models and the structures in Prague. That's how the castle was built. Hi, Hank, glad you're here. So why and how the data model? I think I've gone through that. Simple sets help you get models accepted. Now, there's a real benefit in this, that this approach fits right in with the NetComp, RESTComp work in their data catalog and registry. What you can do based on their stuff is you can say, I want this subset to go in my data store for configuration. Okay, and these are the model drafts in NetComp that will allow this. This is why we think this approach may be successful for people actually deploying. Now, again, the data model catalog and the open config, if I remember right, Hank and those in the hackathon, they finished their hackathon version of it. So again, there's hackathon early code. We're following early code movements. Go ahead to the next one. Now, that was a long explanation to go to this slide. At the top, we have an information model that goes around, and here I'm going to dance outside of the box. I apologize, unless we have a pointer. Do you guys have that thing? Yeah, that would be nice too. I could use the spoon. Okay, one of these makes it turn red. No, that wasn't it. Wasn't it? Okay, guess the red pointer is not. Oh, thank you so much. The top one? Yeah, okay. Thank you. Okay, so over here is our key model, that key structure like the castle with the capability model. Then we have a client-facing information model, a HIUN's registration model, the monitoring model, and then below the capability model is some detail from Frank on the security policy. This creates an information model. Now, as you look and you review this, please tell us what you think. Now, Nabil's back here for Kumar, but this one in our group thinks that was discussing things this morning really thinks that the client-facing model ought to take an approach of intent. Okay, how many people know what declarative and intent models are? Okay, very few. Pardon me while I give the rest of you a moment. Declarative versus descriptive is, if you're descriptive, you describe how to go to the store. I need to go to the store to get aspirin. I need you to go down the street over there, find the drugstore, go inside, pick up the aspirin bottle, pick up the Excedrin bottle, and come back. Declarative says, please go to the store, pick up aspirin. Okay. The declarative model in a client is much more powerful because the client doesn't have to know what the interior of the security model is. It says secure a path from these two to these two, or engage in a threat analysis, a threat prevention, or some capability. So Nabil, I hope I gave a good description. We all felt like this client model should really be declarative. We're working on that. These models are still in the info model here, a work in progress, but we've made some progress along that, and that's what's different. All the rest are probably what you expect for info model. Now, the reason we take this is some of this is new thoughts, and this blueprint will help us build a good castle. Down here, we took the build a little. So this capability model that's underneath, under the same point, is a subset. Now, we think this is a workable subset based on the hackathon code that works underneath in the base model. It may be an incorrect subset, but this is for you to review and to work on. There is hackathon code, so try it. This is a build and try. There is the interface data model, which is trying to take, which is not 100% aligned with Kumar, but was enough to do the hackathon stuff. So you have to look at the Kumar model and the Kim NSF facing models to see what you think is a declarative thing. Here it's secure connection for this time, this location. At Jung customer, excuse me, I pointed at the wrong. It's Jung's customer facing model that is equivalent. And all the comments I just said should have said Jung, where I pointed at Kim. Kim is at the NSF facing model, which is the thing that goes between the controller and the actual NSF discussion. I think we've gone through this type of discussion quite a bit, so I won't repeat it. Hands, anybody want me to repeat the substance of what's in the NSF facing? Okay, no hands, no talk. Okay, then this is the registration model, and this one is new. Again, based on work that's being coded and deployed that matches the Zhang I2S interface monitoring model. So that's our model discussion and why we paired things in this way. We think that the capability model from the team is ready to go along with this, and as our key model, just like the key building, we're going to ask the working group from the authors to adopt both. Then we'll ask you to adopt other pieces from the models. Questions on our little review and these models and structure? Is it after lunch or am I confusing? Okay, no questions. I'm impressed.
Yes, thank you very much. And maybe at the very end, after all the presentation, talk about their data model, information model, then we can discuss a little more. Okay.
Diego Lopez, Telefónica. More than a question to Sue, I would like to remark one thing. Well, after this morning, the discussion this morning, I was thinking that precisely the capability model is not precisely a model on the on what happens in the different interfaces. Is a model so capabilities can be registered. So what we have is precisely on what we're working here is about an open model in which you can deal with different set of capabilities. So in the sense that we are open to registering different kind of stuff. Okay. And this is very important because what we have is the placeholder for the other different models. As the idea is not that people has to take the capabilities and go for the capabilities and specialize them or extend them. It's about that the capabilities model provide this support for declaring the capabilities and manipulating them. And this is something that we have to be a little bit careful on.
Okay, so eventually at the end of the day, we have to develop the model for the client facing and the model for the NSF facing. So would that be, in this one, will be those separate information model to describe them?
In principle, both of them should be based on the, I mean, if you ask me, I think that they should be based on the capability model.
Okay. Okay.
And whether what we make is a general model that is more detailed in one case or the other, this is up to the group, and that's something that remains to be decided so far.
Okay, thank you. So that's our last slide for the chair. Sorry for taking so much longer. We're supposed to do 5 minutes, but we went a little longer. So next one is the hackathon. Let me bring up the. Okay, sorry. Oh, where is the hackathon? Okay.
Oh, this one.
Just this one, right?
Oh, no, this is it. Could you have so left for
I got this one. This is another one. This is the poster.
poster?
Okay.
I think the
Hackathon poster. Hackathon report, right? Okay.
Okay. So this is Jaeon Poljang from Sungkyun University. Next slide, please. So the objective of this hackathon is to show the validity of our design of data-driven security management. So this time, 7 graduate students from my university, SKKU, we prepare for last 3 months, and then this last the weekend we try to tune our code and prepare for the presentation. So next slide. So this hackathon is collaboration work with the university, and Korea Telecom is ISP vendor, major ISP vendor in South Korea, and also IETF is government-supported research institute. So 3 organizations are working with for the hackathon. So the Korea Telecom, they provide the real applications for I2NSF services. Next slide, please. So this photo shows last weekend students and Korea Telecom researcher and I are working. Also, Sujan also dropped by our hackathon table. So we work together, and also we presented our work. And then this time we got Best University Award again. So last year, Seoul meeting, we get best group work. So indicates our working group are working very hard. Next slide. So next, you already know the concept of I2NSF. So the goal of this hackathon is we try to show the first the application is a firewall. The second one is content-based security, such as a web filter. And then we combine using service function training, SFC. We showed according to the Frank information model case, the investigate the packet using the firewall, and then if this content should be investigated in detail, in that case, that packet should be forwarded to the DPI, deep packet inspection. So in order to that, we implemented SFC. This time, we try to follow the SFC working group's solution. Next slide. So contribution of this hackathon, we showed the POC, the proof of concept for I2NSF using open sources. And also we showed the validity of our simple data models. So even though the data model is simple, but looks like the powerful. And then we showed the feasibility of a data-driven approach. Next slide. So those are a bunch of the open sources. So we, especially this time, we used the XSLT, extensible style sheet languages and transformations, which means high level, the policy specified I2NSF user, that high level policy translated into low level policy will be delivered to NSF. Next slide. So this figure shows the network configuration. So left-hand side is enterprise network, right-hand side is the service website, Facebook, web, YouTube. So this time we implemented the firewall and the web filter, which means based on the port information, such as a web port is the 80, right? So if traffic is from some client, such as employee, the traffic is web, we can filter out. The second one is if the content of the web, the packet containing YouTube or Facebook, we can filter out, which means we can perform web filter. Next slide. So this figure shows the configuration. Next. So we can show the firewall. Next. Secondly, this one is web filter. Remember, we implemented using SFC, so service function forward, and then originally the file or packet is forward to the web filter NSF using SFC. Next, please. So we uploaded our document and open source our code into GitHub, and also we uploaded our the video clip explaining how to install and how to test. Next slide. So this figure shows GitHub. Next slide. Finally, we got many lessons from the two hackathons, and we showed the POC. The data model, I think, should be the simple to readable for the audience. So also we showed the current existing open source are enough to implement our I2NSF framework. And also we showed the feasibility of our approach. Okay, that's it. Thank you. Any questions, comments?
Thank you very much.
Thank you.
They
Yeah.
also got an award for this hackathon. Thank you. Just a little extra note for hackathon. So hackathon is IETF work, and just recently, not too long ago, Linux Foundation started a new project called the Security Controller Open Source Project. There are like 5 companies currently in there, like Intel, Alapato, Huawei. I think there's 2 other. I don't know, Nokia maybe. In there. So I've approached them. They were supposed to come here, give a presentation, but time-wise, it's too early for them to really wake up to do the presentation. So next time if we meet, they probably be able to give us an update on what they are doing. And they are hoping to use I2NSF interface as the APIs to guide their work. Their work is mainly for the controller part, just like the logistics, like the logics of getting the interface from client, being able to translate into an SF-facing interface.
Kathleen Moriarty, AD, so you're following that work, and if we need to do liaisons and whatnot?
Yes, absolutely.
Okay.
Yes. Yeah.
All right. I'm sure it sounds like it's too early for that, but.
They just started, they just formed, yes. Yes, please.
Frank Xia, Huawei, and I have a question to Paul. Do you have a future plan to maybe in the next IETF meeting to do more hackathon test about the new interfaces such as the register interface or the client-facing interfaces? Because I think after this meeting we will output some new content about this part. So I think if we can do hackathon, it will be very helpful.
Yeah. Basically, currently we already implemented the monitoring on the information model. So and also this time we implemented content security. So such as the web filter. So information model getting the more detailed information. We reflect that one into data model, and then we can implement it. Of course, next the 100 and the Singapore meeting. So we implemented that once. Okay, Diego, you go ahead.
Yeah, it's more related to the open source stuff rather than. I mean, normally open source projects are very reluctant to making anything that sounds like a liaison or whatever. Just they come, will tell us what they are doing, and we can try to influence them. In fact, I knew about this project some time ago because, well, it was in the minds of some people that are working with us. Well, it's rather interesting, and I tried to push them to use the I2NSF ideas, and I'm confident they will be coming here, and we will have even managed to convince at least a couple of guys in Intel to participate in the I2NSF. Personally, I'm on it, so it's. I hope we will manage to have them. And well, it would not be a bad idea if you bring some of your results there as well. That could be because this is what we're running code, and this is what they're looking for.
Right, exactly.
Okay, so we can discuss that offline. They just started like a couple months ago, so they are waiting for some kind of substance from us to give to them as well. Okay.
And code, bring the code.
Okay, sure. Okay, thank you.
Okay, thank you very much. So next one is applicability. Is the the capability draft. Yes, you did.
Hello, everyone. It's Frank Xia, Huawei. Okay, I will give an introduction of our latest I2NSF capability information model draft. Since it's a basic information model for a lot of I2NSF data model work, so we warmly welcome everybody can give us good feedbacks. Okay, firstly, let me say. I think the whole point or the key point of this information model draft is that we define we propose an information model for capability, for the security capability. So that's the beginning of the whole thing. So let me explain what is the capability. So I think maybe it's very easy understanding. Actually, for us, the capability is a function that the network security function can provide, and it is not dependent on what is its device model or it's visualized or it's physical. They are all not relevant. But we want to define the logic function which NSF can provide, and so it is an abstract concept, and it should be very flexible to represent the functionality of the security functions. Okay, so in addition to this basic concept, of course, we also need to define how to operate, how to manage this capability, because all our following work is based on how can we define it, and then how can we manage it. So then I think if we have the capability information model, then we can use it to build and construct our security policy model. So that's our way to push this work. Okay, next page. Okay, this is a modeling picture. If somebody see it first time, you may feel not very easy to understand. But please read it more. Actually, it's really helpful because it firstly you can see that in we have the external data information model. So based on this model, it can be, for example, it can be the super information model, or it can be another good information model. But it did provide us some very useful policy information element that we can use to construct our security policy model. And that's a step, but that's out of scope of I2NSF work. We can use it, and then we have two branch to inherit from this very basic information model. The left branch is that we try to define what is the security policy. So the security policy that I can say that currently we use the ECA model. So it's called the event, condition, and action. We use this model to describe the any kind of security policy. So it means that we use different kinds of event object, condition object, and the action object to compose our security policy. That's a basic way. And if you can see from this picture, it's very similar like some class definition. We can, based on very initial class, and then we inherited, we extended to define our model. And in the right branch, it's our capability information model definition. It's a little bit different from the security policy. Actually, the capability information model is about what is the function of this NSF. So it used to advertise what this NSF can provide and register it to the controller so that the customer can use it. So that's a different thing. So we have you can say that we have two branch of the information model. Okay. So in this page we want to explain a little more detail about what they are the security policy and what the capability information they want to specify. Okay, the security policy is used to define the behavior. So it means that we define the security policy and tell the security devices what you should do, how to do. So, for example, when something happened and when you detect some traffic, how to react to it. That's what we want to do by the security policy. But if we talk about the capability, it's another story. It's before I use any security capability, I need to know what we have. So I need to some mechanism, some information model to express which functionality or which feature that NSF has. So we need another way to express it. So that's another information model. Yeah, and but if you see our title, actually the security policy and the capability information model, they are the duality. In essential, they are the same thing, but they use in the different objective. In the later, you will see how we define them respectively. Okay. So let me emphasize our way to define the whole information model. Actually, to achieve the scalability and to achieve a model-driven approach. So, of course, we cannot define a lot of security policy model and calibration model for every kind of network security function. So our way is that we define several kind of capabilities. They are the very basic element, and then based on our defined capabilities, we use our security policy information model to use them to meet different security requirements. So everything starts from the capability information model. Okay. Okay. So I think I have already introduced what is our current model. It's the ECA policy model. So event, condition, action, policy, rule. Policy rule, of course, is a container to contain all these elements. But in addition to ECA, we also think that we need another mechanism to make our policy more flexible and more useful. So we added the resolution strategy. So it's used to for example, I have several security policy rule. So we can use this resolution strategy to decide how to use this rule, how to combine their match result to decide my final action. Sorry. So that is very useful to construct a very complex or very intelligent policy. And also we have the mental data. It is also used by the resolution strategy to define also to define how to map to the final actions. And also we have default actions, which means that if I cannot match all the conditions, what can I do? So we can do the default action. So that's our currently all the element of the security policy. Okay, and after introducing the security policy, I want to introduce the capability information model. So if you can follow my introduction before, so the capability information model is I think it's obvious to you. So it's just another expressing way to define the capability model. So here you can see that we have those basic elements. We have the action set, we have the condition set, we have the event set, and the resolution set, and the default action set. So we use some capability algebra. You can consider it as a set theory. We listed all this information, all these capabilities as a whole to express what I can provide in the security perspective to our user. For example, I have an action set which include deny and pass. So that means that this network security function can filter the traffic. It can also pass the traffic or other actions. Okay, so by this way, network security function can very easily to express what he can do to the security controller or to the client. Okay, and then if we have this kind of definition, we can do some more calculation or some more operation on them. For example, we can do the addition and the subtraction. We have two capability. There are two function set, and we can do the addition of them. So that means that we can get a more powerful capabilities. And we can do subtraction, which means that I don't need some of the capability in that model. So I can subtract it. In the future, we think that maybe we can add more on this operation. So I think I'm almost finished about this information model introduction. About future work, I just want to say that for make our document core content short, so we move a lot of example or specific information model attributes to the appendix part. So they are just for the example to show how to use it. But of course, they will never be a complete set of the security policy information model and the capability information model. So our question to the chair or working group that I think maybe it's not a question, but we just want to say that we don't want to do a thing that cannot finish it. We just list some typical example in the appendix. That's the current way we do. And the next page, please. And I think we still think about another enhancement to current information model. For example, we want to do, in addition to current BOR operations, maybe we can do more on the condition and the event clause. For example, we can introduce conjunctive normal form and the destructive normal form to apply on our condition and our event to make our logic more flexible and more powerful. And then, and also, we're also considering we can do more things on our event and the condition clause, such as we can, for action, we can define different policies on how to implement the action. We can exit the first action or execute the last action, or depend on the priority, execute which action. So I think there are all the details, technical details that we maybe need to add in the future version. We are considering this, and we are very welcome. Anybody can give us more advice or good suggestions. Last one is that about the decorate mode pattern. This is a tough decision. We are not yet decided. Decorate model is a software design pattern that because currently we design the class, so decorate model can provide some of the benefits. For example, it can be load and run in the runtime. So it is managed in the management perspective. It is very efficient, and it can save a lot of manual configuration and manual modification. But it's more complex than current static inheritance class design. So we are not yet decided if we should choose this way to make some modification to our current model design. So we like to hear more suggestions. I think that this page, if you have time, you can see. I don't want to waste too much time. Thank you.
Thank you so much. We are late on time. So.
Yeah. So we are running considerably behind schedule. If everybody could save 20% on their time, then we won't have to push anybody off the end of the agenda. Or if anybody wants to come up here and commit ritual suicide, that will also work.
Okay, thank you very much. Thank you. So next one is applicability. Thank you. I'm having trouble pronouncing that one.
Hello, this is Paul Zhang. So this draft motivation is applicability is one of our milestone item. So based on the hackathon experience, we show out I2NSF can provide security services. The one thing to note is the I2NSF providing physical VNF and also a physical network security function, also virtual security function. So it turns out using the SDN software-defined networking can leverage the security service. Next slide. So the combination of I2NSF SDN case, SDN switch can perform the simple firewall services such as forward drop metering. And then the complicated security services can be done using the more complicated NSF running on top of NFV or physical devices. So, and also I2NSF policy rule enforcement case, we can using SDN switch and NFV or physical devices, the network security function, we can using two things to improve performance. Next slide. So that's why we have augmented framework, which means the bottom we can have the SDN network having SDN switch. So as a result, security controller and the switch controller, usually a switch controller, we can say SDN switch controller can talk to each other using NSF facing interface. Next slide. So the information and the data model for I2NSF during our hackathon, we implemented the partially consumer-facing case partially implemented, but the next hackathon we fully implemented, but consumer-facing, it is called the client-face interface. Information should be enhanced in terms of ECA the paradigm. And NSF facing case, I think the mature. So I think at least the security network security functions such as a firewall is fully implemented. And also restoration interface case, we can register NSF and NSF capability. So we are planning to implement next hackathon. So this applicability case, we can show these three interfaces defined I2NSF can be used. Next slide. So this figure shows the flow, so you can aware, right? So the high-level policy and low-level policy configured. Also, low-level policy can configure the security switch controller, and then the SDN switch can configure the using OpenFlow or I2RS. Okay, next slide. So this draft explain the three use cases: firewall, VoIP, PI, and DDoS attack mitigation services. So due to the time limitation, I can skip. You can read the slide or draft. Next. So you can skip. Yeah. So use cases, I mentioned the three use cases. Next. So we can skip the use cases. Next. 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 So next step, we can also include more use cases, such as SFC-based security function training will be added, such as the firewall and the web filter, and firewall and DDoS attack mitigation. We can combine using SFC. So SFC is also one of our group's draft. So also we can reflect the Frank information model, so we can improve our NSF facing interface considering content security and attack mitigation next time. Okay, thank you for attention. If you have question or comments, please go ahead.
So the next one.
Okay.
Thank you very
Thank
much.
you. Yeah.
So what is the next one? Agenda is model information model monitoring. You have the slide? You didn't send me the slide, right? Do I have them? You just send them to. Do you have them? Maybe you can use your laptop.
What is this? Can you display?
The monitoring.
What is this?
Oh, yours is the big one?
And my question is what this is.
Oh, okay.
Great. We have them in your inbox, your email inbox. But what is this interface? Is it display board?
Display board, yeah.
Thank you.
Okay.
So what is So what are you doing? We're doing information model, right?
The monitoring, yes.
Can you search and everybody see this? Want to see this? You have them? I have the slide. It's in your email inbox.
So is it from you?
Yeah, this is from me, yes.
Okay. That's one thing I didn't get it. I got a 2 bus. Oh, okay, I got it. Okay. Okay.
And should I combine both slides sets you have? Then I can do it at. Then I can set time maybe. Paste it here. Hi, this is Hank. I'm apologizing for the mix-up of apparently slides here.
Okay.
So we are starting with the information model for monitoring of network security functions. And yeah, we just skipped the most important part here. It is ultimately intended to deal with the huge amount of information that will be emitted by functions. And with that, we not only mean the I2NSF functions that will be standardized, but also by the legacy interfaces that are already pushing a lot of information as notifications today. So the content here is not only the I2NFS events that are of interest because they are already processed by a rule or somehow outputted by the I2NSF system itself, but also raw data that may be of interest and was not assessed yet. The policy here, or the general rule here, is that the consumer of those notifications decides. So we again will reuse the existing model of capabilities or ECA policy rules and just allow them to consume notifications that are coming from outside the scope of the I2NSF. There is rough consensus in the terminology team. John Stressner, who is basically in charge of the ECA logic, agreed to this, but we have no text for this because John, unfortunately, was unavailable in the last few weeks. So unfortunately, he's also not on site. We skipped dropped the stuff with the alerts and the alarms. There was too much discussion about an arbitrary definition of classes here. There will be an implicit definition due to the chaining of policy rules, though. So this escalation of severity or confidence will still occur, but they will just be named events at the first time and be annotated with metadata, basically telling what it is. We at the hackathon were exploring, next slide please, the potential solution drafts that are existing in the scope of the NetConf realm. So we basically implemented cutting edge firmware that was deployed on Friday, and software, the NCC and the NC client open source software is available on GitHub. On Wednesday, this weekend at the hackathon, we were able to do periodic updates and on change updates from the USA and the PRC. So globally spending, creating a notification flow that was then consumed by a component. This was first intention was to build a second component. And then we realized that a second component in this scope of first proof of concept is pretty much looking like a I2NSF component. And also the function capability semantics are quite similar. So we a little bit saw this coming due to the convergence of the two terminology drafts, but now with the running code, we can actually understand this better. And the rule used here to create I2NSF events was the filter expression for a subscription onto a or multiple Yang modules. And Sue, who is in the room, you probably will love to hear that we did ISIS on change updates and also OSPF table changes. Okay, so talking about legacy interfaces, next slide. This pretty much I already spoiled, so we will use the notification system because notification is a thing in Yang. Also, live data we will push via Yang probably, at least this is our route that we pursue at the moment. Poll mechanisms has pretty much more of a legacy thing, as are the log files that are created and retained. We call this records because it's not only all the logs, it's also databases. So specific agents with specific rules will create events from those. The end. I will go through this really quick. We also have an early proposal of a categorization system for information monitoring, because how you get it, like if it's a query, was it a subscription, what it is about, is it live, is it a record, is it declarative guidance, how you should be, imperative guidance, how you should do things, or an assessment already that the outcome of a rule. Is it a raw aggregation or already a complex set of rule result? And then again, what about the function is relevant here? Context is introduced by John Stressner. He would elaborate on this. Unfortunately, he is not on site. So the next slide, please. We investigated, of course, next to Yang subscription, other ways to create telemetry. There's an effort going on with co-app PubSub. Unfortunately, the authors meet tomorrow for their breakout meeting, so I couldn't get updates on that today. XMPP Grid is under severe restructure. It will be fully compliant to XMPP and JABS, and the XMPP Grid console is at the moment confirming that this is a standard, or this could be a standard. So it's basically not violating any XMPP rules. So there are alternatives in the way to get telemetry, not only for monitoring, but also between functions. But this is, again, future work. So next steps are deciding on here what to do with the categorization model. You saw a approach here on the slides, and we will also have to focus on intervals, so freshness of information, because that might be of relevance to security. So this was, I hope, fast enough.
Thank you. Thank you.
So thank you very much. One of the challenges we had in Routing Hat was going through the categorization. The fact that you've actually done that in the security piece is impressive. In routing, we do it in order to support high availability and sub-second flow and failovers. Security, it's really good to see the same categorization. Thank you very much, Hank.
You're welcome. Your input always is appreciated. The pieces you threw at me throughout the last interval were very, very helpful.
So can we go to that later? Because I want, this is all the NSF facing information model and data model, so make it more consistent. So next one is the Sue Harris capability data model. Okay.
Okay, if you've got the
Just hand me the.
This one doesn't
Yeah,
work.
it's okay.
This one doesn't work. You
It
have
doesn't work, okay, then you get the, get to do that.
The other one's right there.
Yeah, okay, I get that, thank you. Okay. Again, we're taking the approach of high-level thought for the room, in case you've coming into this new. We're taking the approach of implementing, like I said, a piece of the large blueprint and working on it step by step through hackathons. If you're interested in playing with this, please download the code from the that has been created from the Korean team, and please, I'm sure they'd love comments. This is to help get early review, early fail on anything, but we're starting to see, we think this is close for some of the product groups that we've talked to. Okay, and also the Linux theme. The groupings are what you would think from the original capability information model. We're grouping based on network and security control, the content control, the mitigation control, and the capabilities information. Remember, this just should look like Frank's original thing. Go ahead to the next. Now, there's a difference between the NSF-facing Yang data model and the capability model. The NSF is used to configure the rules of policy into the NSF, and the capability data model is used to retrieve it. We're taking the idea that you want to know what you're supposed to do, and then you put it down. This provides what we had agreed in the charter, which is to provide what we're doing and then allow flexibilities for different people with NSFs to download things. The benefit of having the good open source that the team did is you can see it based on the open source filters. Please go ahead. This, I think, is just showing the same thing in a picture. Keep going. And this shows that you're getting a directory list interface. And this shows that we've actually been doing the fact that we've used this for SFC. Okay, in case you missed the last hackathon and this hackathon report, let me give you a little background. There's two cases that we're looking at that are real important. Phones and forwarding with the classifier using the SFC stuff. Really good, and this isn't on the slide, so I apologize, information that this packet data load, we've taken a look at, not me, the good team and the students have looked at what happens when you actually monitor the SFC work from a centralized point of view. If you distribute it, what they found in their initial implementation is you really ought to distribute these type of security functions throughout the network because it's more efficient. So with that high level, let me go show you that, you know, the idea is the packet comes in, you have a query-based capability, you download the information, and then you're able to forward it. This allows you, if you have a distributed model, to get very efficient with the SFC forwarder, either for specific functionalities such as mail cleaning or filtering or date packet inspection or other things within the network. So please, we're giving you this as a model, but we're trying to keep now improving the contents of this for the IT resource. Again, work on a little piece, build it, test it, provide you models. What we really would like some feedback is if you take this home and try it, we'll do this. We'll verify the next set of stuff as we go. Thank you.
Thanks, Sue. I saw Paul send a note to the SFC working group about another SFC-related draft, and seeing this, I think we maybe should sort of correlate all of our SFC-related drafts and make sure that that working group knows what we're doing.
I did take a time and tell the chair about what I thought was the high-level order. I will make sure that I also go back and correlate that with that working group. But I told him what I just told him, that the important thing for their working group is the fact that it looks like in our early thing, the distributed filtering for security functions was more effective. And I'm sure he'll share that with his team as he wishes. That's Joel Halpern. By the way, for people, there are too many chairs there. Yes.
Kathleen Moriarty, AD. So a couple of general comments. A few of the drafts, some not adopted yet, seem like they are overlapping enough with other ones that if they move towards adoption, like the applicability statement should get folded into something else. Terminology, we may want to fold into one of the protocol drafts. It'll have an easier time with these formational type drafts with the IESG. And the other one, we've been hearing about development work, which is really exciting. Can it also get plugged into CodeStand so that we could track what drafts have implementations?
Oh, that's really good. Yeah, we'll do that.
Okay, great. Thank you.
Adrian, you will help, and Linda, you will help guide that, because we had kept the terminology as a standalone draft. Frank, did you get that in the notes so I make sure we follow up on it? Thank you.
Hi, this is Hank, and this is about collapsing terminology. And you, of course, know that I have no to speak for John and me at the same time. I think John would not really like the dependency onto a protocol or a specific model, because there's an umbrella. They would always include terms for other drafts, and they are not at the top of the heap, so it would never align. So if there is no actual hard pressure and reason to do it, I would not recommend to do it.
There will be, Frank.
So, yeah.
We'll take that offline.
So a document won't get past my review if it's redefined or even copying a definition from somewhere else. And I think the point of having the terminology document is to pull that all together.
Right, and it's fine to combine it with another document. The formational type documents are not viewed well by the IESG, so there's a lot of pressure, and there's a lot of pressure right now on that. I know Sue's been through it a few times, either as shepherd or as an editor. So if I'm suggesting a protocol document because there's going to be more support for those, and those do require the terminology, right, moving forward. So if it's like a core document that's pivotal to the working group that you're going to be referencing anyway from other documents, then it's a good one for the terminology to be referencing.
Thank you.
If there's such a place.
I think the place that it might be, if we put it in a protocol document, it might be useful to put it in our key protocol document, the capability protocol document.
And that also makes them, it's part of then a standard struct document, and it's going to get more review.
Okay. Thank you for that advice. We appreciate that.
So next one is the NSF facing data models. So this is in complement to the capability data models.
Yes. So this is for the NSF facing interface data model. So this we report the previous version, but we will reflect the latest version next the revision. Next, please. So the Sue already explained the difference. So skip. Yeah. Next slide, please. So this time we updated the event component and the action component using the more concrete data types. Next slide. So this showed we replace the integer type, unsigned integer type using the enumeration type. Next slide. Also, we previously used the case. This revision, we use enumeration for ingress action. Next slide. Also, previously here apply apply appropriate action, more advanced action, contents-based action. For example, we try to simplify the data structure. Next slide. So next step, we also include the content security and attack mitigation. Once the information model providing more detailed information, we implement the data young model. and also we implement for next hackathon. Thank you.
Thank you. In terms of time, do you have questions? No. Okay, we'll go to the next one. Okay. So the next one is the registration interface, right?
Yeah. Hello, everyone. This is Sang-Won Hyun from Sungkyunkwan University, and this presentation is about the registration interface, information model, and data model. Next one, please. Yeah. So the major objective of the registration interface is registering an NSF and its capability into the system. So our information model and data model focus on that function. And also, in some cases, the security controller may want to request the developer's management system to create a new instance or destruct an existing instance which is underutilized. So in these two documents, we designed the information model and data model to support the following functions, which is registering a new NSF instance and its capabilities into the security controller, and additionally to request dynamic instantiation or de-instantiations. Next one, yeah. So this slide is a summary of the update, and in this new version of the information model draft, we added the portion of performance capability, and we also updated the Yang data model to align with the information model update. Next one, please. So this figure is briefly describes the registering process through the registration interface. So after creating the new instance by the developer's management system, the developer's management system registers the created new NSF instance and its capability to the security controller. So the existing information model and data model are used to describe the security capability of an NSF instance. Next one, please. And we thought in some case, in the following cases, the security controller may need to request to create a new instance or destruct an existing instance. So this is the possible cases. So the first one is in the I2NSF framework, on NSF can trigger an advanced security action, which requires another type of NSF for further security inspection. In this case, for some reason, the triggered NSF instance may be unavailable in the system. In this case, the security controller, to serve this advanced security action, the security controller need to request this DMS system to create the required NSF instance. Or if the security controller can detect an NSF instance is under congestion, then the security controller also need to request to creation of a new additional instance. Next one, please. And this is the summary of the version update, and we have added an additional portion of the performance capability to describe several type attributes of the type of resources. Next one, please. Yeah, so in the future, we will extend our hackathon implementation to support this registration process via the registration interface. And we will also do some investigation on the feasibility of dynamic instantiation or de-instantiation. Yeah, thank you.
Thank you.
Diego Lopez here, not willing to ruin time management, but I see that this is, I mean, looking at what you intend to do here, I see 2 points. One is that this is more connected with the protocol rather than an information or a data model, right? So, I mean, calling it an information model or data model probably could be a little bit misleading. This is one thing, because we're talking about how you interact with the different and how you actually retrieve capabilities or push or pull capabilities from or to the NSF. Second, looking at the elements that appear on the screen, I see I mean, it's somehow it's very much connected with the Henk was presenting, because we're talking about status. You are talking about memory or the processing, the processor load and things like that. That are, to some extent, they are events as well, or some kind of telemetry. So what I would encourage is that you try to converge with what Henk was presenting, so we have a single set of telemetry data in general, whatever they are, events or measurements or whatever. So I would encourage that you converge with them when it comes to the data model and the protocol, because this set of protocol choices that Henk was showing precisely would be very good to experiment with them in the next hackathon. That's a comment.
Thank you very much. So next one is our remote presentation. Andrew, do you know how to?
You don't have to touch anything.
So he's there.
He's there. He can put himself forward.
So I don't have to touch anything.
No, you don't.
It's Gabrielle.
Gabrielle, are you there in Meet Echo? And can you should have a blue microphone button you can go for.
Hello.
Oh, we hear you. We don't see you, but we hear you.
Okay. So, hello.
We see you as well. Perfect. Go for it.
Well, hello. My name is Gabriel Lopez from the University of Murcia. Cheers, from Spain. I'm going to present the update of the draft, the title Software Defined Networking Based IPsec Flow Protection. Next slide. I don't know if I can move the slides or.
I moved the slide for you.
Okay.
Oh, I only moved the slide for you.
Okay.
So
thank
this
you.
is
Thank you. Well, first of all, there's a quick reminder of the main objectives of this draft. The first one is to describe the architecture for the IPsec management of security association by means of the ASTM paradigm, and also to define in this case, the network security function facing interface to allow the security controller to manage and monitor the security association between our own network security function. For that, we have to define the YAN models for configuration and state data for the management of IPsec. Next slide, please. Okay, in this draft, we propose to use 2 cases. In case 1, the network security function implements both the IPsec kernel stack and also the key management protocol, in this case IKEY. And in this case, the security controller is in charge of provide the network security function with the required configuration information for IKEY, for the ASPD data, the security policy database, and the policy authorization database, but not the security association database that is the security association are created in runtime by means of the IKEY negotiation at the data plane. In case 2, we suppose that the network security function only implements the IPsec databases, the security policy database and the security association database, but not run the key, in this case, the key management protocol. So in this case, the security controller has to provide the configuration for both the policies and the security association into the network security function. In this case, the network security function, oh, sorry, back slide. So just to say that in this case, the network security function will have only support for IPsec, and all the key management functionality is moved to the security control. Okay. Next slide, please. Okay, changes from the previous version of the draft. We are talking about this draft is version 03. We have focused this new version of the draft in the gateway to gateway and host to host scenarios. The idea is to define the model and to deploy a testbed to test those scenarios. And the work for the host to gateway, in this case the road warrior scenario, is work to be done for next version of the draft. We also have improved the discussion among case 1 versus case 2, following the comments received through in the mailing list and also in the previous presentation of the draft. Probably the main contribution is the Jan configuration data model. In this case, we provide in the draft just one Jan file, providing the module. Sorry, back slide. Sorry, can you back slide?
Is this the right one?
Oh, no, I can't see. Okay, just to say that we provide the Jan module for the IK configuration information for the SPD, SAD, and PID configuration. And I said before, we provide just one file, the Jan model in just one file, and it is up to the security controller knowing the kind of scenario to be applied in order to decide the part of this model to be used. For example, if we are talking about the security controller is deploying a case 1 scenario, then it has to make use of the IKID, SPD, and PAD data models. But if the controller knows that has to deploy a case 2 scenario, then it has to make use of the SPD and SAD data models. And in order to define this Jan specification, we have make a deep analysis of the RFC 4301 to describe the requirements of the security policy, the security association, and security authentication database. We have also analyzed RFC 6296 to analyze the configuration required for the key management protocol. But also, we have analyzed open source implementation like Strong One and Loose One. But again, here we call for the review of the experts to try to help in the improvement and the tuning of this model. Next slide, please. We have also the setup of proof of concept, making use of this proof of concept only cover the security controller and the network security function, the data plane. It doesn't cover the application layer in the SDN architecture. And we have made use of netconf, like the Southbound protocol, making use of the near-to-peer implementation, and the YANG model, including in the draft. We have tested the host-to-host and gateway-to-gateway scenarios with different transport mode, tunnel mode, authentication, encryption, combination of authentication and encryption, etc. For case one, in case of the network security function, we have made use of a strong one for the AKI implementation, and the API provided by the strong one, in this case BASIC, in order to allow runtime configuration of AKI. And for case two, in the case of the network security function, we have made use of the PFI key version 2 for the SAD configuration in the network security function, the KEM extension for the ASPT configuration, and also the XRFM for SAD and ASPT in Linux systems. So, next slide. And that's all. Any question is welcome.
Any questions? Maybe we don't have much time. Just try to get 1 or 2 questions.
I'll say it quickly. This is good work. IPsec for the flow protection is good. However, in practical cases, many cases, it doesn't work when your NSF is inside the corporate boundary, and there are policy rules which won't allow it. DOTS has been dealing with this same issue in DOTS. It needs to be covered and be taken care of, but it's not the sole solution because it doesn't always be. It's not always deployable. That's all we need to have some caveat in discussion with that point in the draft.
Yes, yes. Well, it's true that we have not analyzed all the cases, but that's why we request for this kind of scenario that could rise some problem in the model. Just to say that we have followed the RFC, we have tried to be very accurate in the definition of the YANG model. So in theory, we are based on the RFC. So of course, those scenarios could appear, and we want to try to analyze these cases.
So next one.
Okay, you have near. I've said it on the IPsec mailing list, not on I2NSF mailing list. One of the problems I see with this model is that in a lot of time in VPN scenarios, your NSF is not in the corporate bounds, but in some kiosk at the mall somewhere, and the network there is not known to the administrator. So the information about what is behind what the address the NSF has and what addresses are protected behind that gateway are known only to the NSF at the start. So the information about all that has to flow from the NSF to the controller. Now, if we build a model where the information only flows from the controller to the NSF, then we have to have some side channels, some back channels where people read off the routing table from the configuration of the NSF and then input it to the administrator. And that's not what we want. We want something automated. That's the point of doing things using SDNs. So I think there should be a flow of information of what we usually call topology information from the NSF to the controllers in order for the controller to build the big picture.
Yes, yes. In this case, we have to take into account that we are trying to apply the SDN paradigm. So in this case, the SDN paradigms has the whole view of the network. Another question is difficult to provide the administrator with the regarding information in order to send the correct, let's say, the current high-level policy to the controller in order to allow the controller to specify the correct network security function. But we have to assume that the security controller has the world view of the network. And I think that is something that, well, we are now see that is required thanks to the deployment of the HD1 solution. And of course, there are a scenario where it could be more difficult to apply, but there are other scenarios where probably we don't have this kind of restriction, and the SDN paradigm could be a good solution for the management of the security association.
Right, and yeah, let's move this along,
okay,
please.
So I agree that the controller has to have all the information. I'm just not sure if that information should come from the northbound interface or the southbound interface. But I guess that should be with the on mailing list.
Can you
Yes.
put that?
Anyway, I think that because just want to comment because this kind of discussion also took place in the last meeting. So probably it's a good idea to have a separate meeting in order to discuss about these kind of things.
Valery Smyslov, Elvis Plus. I'm very much concerned with ICLS case and option number 2. Because first, security controller became a very attractive target for attack. Once you hijack security controller, you get all the keys. And the second concern is that, well, it's could you clarify, please, how you secure keys that are distributed from security controller to endpoints? Because I hope you are not send it in clear.
Yes,
and,
of course.
If you have some security channel between security controller and endpoint, then you've already implemented some kind of TLS, IC, or something, some security protocol. So I don't think you get some gain when you remove IQ2, because you need to have some security, some standard security protocol to secure transport keys. So I don't think it's a good solution to remove IC.
Well, in the SDN paradigm, all the network devices, let's say, have to have a trust relationship with the security controller. That's one of the implications, and that's why the security controller has to have the world view of the network. In fact, those network security function has to be provisioned with this authentication and encryption material. In fact, in this paradigm, in our case, we make use of netconf, we make use of SSL or SSH tunnel between the security controller and the network security function. But in other solutions like OpenFlow, they also establish a security channel because, of course, you are right, the information is critical, so it has to be protected carefully.
Okay.
Right, so I think you've made a really important point, and could you reiterate that point on the mailing list, please, and then we can close on it and actually have it documented. Okay. Thanks, Nabil. And hey, we've got 28 minutes for 50 minutes worth of so whatever.
Thanks. So this draft is about the requirement for the client-facing interface to the security controller. These are the authors that contributed to the draft. Slide. This is really depicting the reference model within which we define the client-facing interface, whereby the client-facing interface is provide the ability to for a user or application to express the security policy in an abstract fashion to the security controller, which in turn decide where to apply those security policies and how to apply them. Then in the data plane, the enforcement point on which are the NSFs on which these security policies end up being configured by the security controller, apply the policies to the traffic associated with the endpoints. The endpoints could be applications, or could be users, or could be applications and user, and any combination of these. Next slide, please. So what has been updated in the draft? There has been some clarification on the requirement preferences between the must, maze, and what's recommended. There has been update based on requirements coming from the ONAG, what stands for the Open Network User Group, feedback from them. Specifically, there were 3 categories of security policies that were added related to segmentation, what people know sometimes as micro-segmentation policies, threat policies, as well as compliance and audit policies. And there are further kind of finely grained definement of different policy blocks that pertain to source policy endpoint, group destination endpoint, group the direction in which the policy needs to apply, threat to group, and so forth. And finally, there is also update related to consistent policy enforcement in case there's update to the policy that will trigger update on the NSFs for the policies that the user is intending to apply. Can we go to the next slide, please? So what are the design principles behind the client-facing interface? Really, the goal in here is to enable, again, a user or an application to express the policies in an abstract way, in very declarative / descriptive way, rather than being imperative and prescriptive, meaning asserting really the what rather than the how things need to unravel and where they need to apply. In that fashion, that means that the user expresses them without necessarily knowledge about the network topology, how the NSF resides within the network, how they're connected, and so forth, because that's really for the security controller to decide about where to apply these things. Having said that, there could be cases where the user or the application needs to express also a policy with certain affinity by which the policy needs to apply to a particular device, a particular NSF or network security function, and that ability exists as well. Can we go to the next slide, please? So there are many requirements. There is no point in going through one by one in here. What has been covered, but suffice to say, really, these policies are intended to be applied in multi-domain, multi-tenant ways. So there are these objects that are requirements for object that identify tenants, identify domains. There is ways by which the policies could be triggered. In particular, that could be event triggered, that could be time triggered. There are requirements on expressing policies that identify the endpoints to which the policies need to apply, whether it's application identifiers, user identifiers, or traffic identifiers, and that the source for these identifiers as well, where they could be obtained from. I think we could go over that. It's not really. I mean, again, we could go through the draft. So, what are the next steps in here? The idea is to add examples to the draft that try to illustrate more via examples how the requirement could be applied. There is need to align the terminology used in this draft with the I2NSF terminology draft, as well as to address some comments on the mailing list. I think there is one from you, Linda, related to here, really to kind of separate what's high-level requirement versus what are the must requirements, as well as to get clarification on what is the difference between what we call in the draft as a construct-based policy definition versus intent-based. To tell you the truth, in my view, it's really what we're talking about really is intent-based, except that intent is being expressed with constructs that are defined by the different policy objects that we'll talk about in the information draft. And finally, we need to continue soliciting requirements from the working group as well to enhance the draft.
This standing was not thank you for your presentation. Okay. It's very helpful. The indemnity that you're the groups that you're using, it would also be good to clarify whether you're using, how you're looking at identity concepts, is it identification, et cetera.
Right. So let me, I think I'll give an example in here, just a brief one. So the idea, I mean, before the people used to define policies that says block traffic from this IP address to that IP address, block user X from accessing application B. The idea in here is to really group things, and rather than define them based on information as such, unless you need to, but you could say block traffic between application A and application B. How many instances of that application exist really is irrelevant. That's up for the really controller to unravel that and expand that policy to the application instances. That's one example. So an application is that case could be identified by a name or a tag, for example. And how that could be, and the same thing to the user. You could associate a user with the user group and obtain that tag or identity of that user group from an Active Directory or an LDAP or something along that line. That's kind of the idea. So you define policy on tags rather than on explicit identity that exists in the network. That could be variant as a function of time. Both comes and goes. I don't know, so that kind of explained at the high level.
Okay.
No problem.
Okay.
All right.
Next
one is the information model. So this is the draft about the information model for the client-facing interface. The idea, I mean, as the information model in general, what it is really, I think Sue referred to it earlier in her presentation as a blueprint to define a data model, or basically defining what needs to be contained in the model. In other words, it's really, as there is one RFC that says how it should be defined. It's about defining really information objects, what information should be defined in them, and the interrelationships among these objects. And that's really what the information model that we're defining in here. The object models and the relationships are really defined in a way to address the requirements and the requirement draft. As I said earlier, there have been few extensions that we added to the requirements related to different policy categories. Some of them are already in the information model, but others will need to be extended. In particular, things pertinent to the audit, for example, category, as well as to the segmentation category. It has to be explicitly mentioned in the information model. But in general, really, the information model is consistent with the requirement draft that we just went over. The functional requirements really is applied to multi-tenancy related objects, so that we have a tenant domain object, tenant object, and the tenant relationship to the domain object, and so forth. And there are also endpoint group objects, which we just kind of defined in the requirement, which we call the user group endpoint, the application endpoint, and so forth. So there are object models for these. No problem. Can you go to the next slide? So there is also threat prevented object that defines where the threat information is coming from, the source of it, whether it's defined based on as URL, threat feed, malware signature, an event map, and so forth. There is telemetry collection objects that also are defined in the information model draft that says what data could be collected, the telemetry data could be collected, the sources from which they are collected, as well as the destination to which they are streamed to, if you will, or reported to, either via a pull model or a push model. That's also kind of the object model captures that. And there is security policy objects that are created using different concepts that we talked about earlier. So really, the way you define the policy instances is you have composite of the different policy blocks or policy construct that we talked about earlier in this presentation. Next slide, please. So that the draft has been updated. If there is any input from the working group draft, the working group would like to hear about that on the mailing list, and we'll discuss and update accordingly.
2 comments about this. First of all, again, I see that there is some overlap with other IEM drafts, etc. So we will need to have and in fact, when it comes to this customer-facing interface, I was wondering whether can move it a little bit. I was wondering whether it would make sense. I mean, looking at the text. The text to me looks more a set of, on the one hand, is extended requirements that are better formalized, on the one hand. And on the other hand, they are more about, most about metadata. I mean, we're talking about the issue, the source, the dates, etc. What looks more to me as an envelope for a general statement, and probably, I mean, and it's something that we will have to go through. Linda was proposing this design team in which we're going to try to steer a little bit all the drafts we have at hand. And probably, I mean, my recommendation looking at it would be probably that we take some parts of what you have there for the requirements and some part of what you have there, try to mix it with what Henk was presenting as well, because we're talking telemetry, for example. This is one thing. The second thing that I'm starting, and it's a general comment, not only to your document in particular, is that it's true that we agreed that we wanted to have information model documents, and that's, to me, looking at of what have been presented and the documents in the data tracker, etc., looking at them, looks to me that this is justified in the case of the capability model, because the capability model is something complicated, so to say, to express. And it's a new thing that we are bringing here in terms of generalizing the whole thing. But probably in other cases, just having data model, I mean, a data model document with a justification, talking about why that data model is built, probably should be enough. So we reduce the number of entities, and we apply this Occam's razor somehow.
So I'll start with that. I mean, as you said, this is probably a generic comment to all the information models in the working group, not just this one. I think probably Adrian touched on that a bit earlier, that there was a decision to create that. I've been in other working groups where people had really forgot that, or didn't see the need to have an information model documents. They've done, in some working groups, we've done them, and then we dismiss them later after the data model have been defined. So they were just used as guidance, if you will, to define the data model. I think which path that will be taken, I guess it's up to the working group to decide, and the chairs.
Yeah, right. And there's no requirement to push every document that started through to RFC. Yeah. Use it when it's useful. Drop it when it ceases to be useful.
Yes, a mix and match. Yeah.
So I think, I mean, to just like to start with that tail end of my kind of comment back to your comment, that that's really where the information model is. It's really very kind of separated from the requirement. The requirements talk about what's driving things, what needs to be done, what the information model is supposed to be. It talk about what information needs to deeply contain in an information model and how things relate to each other. And that's really what the information model is. So it's not really requirements. We have no requirements even in that.
No, but no, this is just, again, from reading it, looks like since you think that I will have the requirements, I will have the information model, I will have the data model, then you push certain things that could be in the requirements, you push them to the information model because it's more complex.
Listen, you're agreeing with each other. Stop it.
Okay, really quick, this is Henk. Hi. The term that I heard already and that I also wrote on our chart on the first day of the hackathon is telemetry. So my assumption is that the solution on data model level will be a Yang-based push subscribe notification-based data model. Data model, so the event stream, telemetry stream. So maybe we can converge all the information items in a corresponding graph that would make use of this one method. You saw a lot of triggers there that are beyond event, time, for example.
That's correct.
So we should,
maybe start absolutely. That. I mean, there is no need to have multiple drafts talking about the same thing. I mean, consolidating will make sense. having pub sub model is obviously the right thing, and having streaming model is the right thing as well, because different needs do exist for this.
Thank you very much.
Thank you.
So next one is the policy objects.
So be really careful here. You have just 5 minutes on the agenda and you've got lots of slides. So cut to the piece that you really want to say.
Okay. Hello, Jessica from Huawei. I'm going to present the latest changes of the policy object draft. First, the background recap. The framework draft of I2NSF has selected the ECVA model for policy rules, and the capability draft has defined many attributes for different condition subclasses. The attribute-based policy rules faces two possible problems: repetitive configuration for the creation, and the maintenance of the policy rules is time-consuming and tedious. So a more efficient way is needed. Then we used the object to express the condition in the policy rules. So there are two main benefits. We provide the reusability for the creation of policy object can be referenced for multiple times, and also brings simplicity for the maintenance of the policy rules. So next slide, please. There are two main changes from last meeting. First, we provide a minimal set of policy objects and attributes. Instead of defining every possible object, if needed, the new one will be included in this draft. So here is a picture of the all the objects we defined, including address, object, and service, application, user, and schedule. And here are some more slides about the details of the policy object. I think we can skip it, and the details are in our draft, and the Appendix A has provided the possible values of the attributes. So next slide, please. Next slide. We think we can go to the examples. The example slide. Yes, for the first. We added an example of the application scenario for the policy object. This is a typical enterprise network topology, which the firewall, we choose an example of the NSF located at the boundary of the network. And we have two kinds of departments, the marketing department and the R&D department. Next slide, please. Then we can make different policy control by defining and using many policy object. And in this slide, the event part is missing. We will add it in the next version. And so next slide, please. So we have come up with some questions and solicit for comments, such as do event and action also need objects? And we can build policy object for both client-facing interface and NSF-facing interface. So and other questions. I think we can talk about it in the mailing list. Thank you. That's all.
Thank you. We have time. Another one. 2 minutes.
Just 7 minutes.
Okay. So what is the name of the
consumer base.
consumer.
So yeah, I quickly report. This time in hackathon, we implemented DPI web filter. So we tried to use existing information model, but it turned out ECA point of view a little lacking. So I hopefully the authors of the client facing can improve. Over to last one. Last one, yeah. So the the hackathon, we tried to, this time we made improve the ECA model. So hopefully the information model client facing probably improved. Next slide. So next, please. So we tried to synchronize with the Shopify information model next time, and also reflect the latest consumer-facing interface. Thank you. Yeah.
Thank you. So next one, Hank, do you want to talk about Tilda?
Sure. I'll try to be quick.
Sorry.
Yeah, sure. Hi. So I'm Hank again. Last meeting we made a very small, very tiny introduction of this document, which is now a related document to the I2NSF workgroup. It is about remote attestation, so we are doing the same thing as Diego. Well, not really, of course. We are doing remote system entity characters authentication. This is using RFC 4949 terminology. So this is basically what remote attestation is. This is composed, we're calling it RAT. 3 RAT activities exist. So attestation actually is only the creation of the evidence by having one or more claims about the characteristics of a attestee, which is a system entity. And so these claims can be used as evidence. Then we convey the second activity, this evidence, to the verifier via an interconnect. Interconnect is a strange term here. It is typically used by people of USB or Bluetooth when you have hard times defining the message bus you're using. It can be GIO pins, and it can be up to the internet. So everything that is able to transport data can be an interconnect. It could be a small form factor SFP interface talking with the module, or it could be a cluster of super high performance computers talking to another cluster. So the interconnect is basically just the thing you convey the evidence with. Verification then happens on the other side. It's the appraisal of the evidence against the declarative guidance defined by second terminology. Next slide. So typically, this is a challenge response interaction model because you want to know that the evidence you get is fresh. It's just the thing you wanted, and the attestee just created it. So you're creating a nonce, and the interaction model is tightly coupled time-wise. TUDA decouples this by using trusted timestamp tokens instead of a nonce, and therefore allows for unidirectional interaction that does not need a return channel. Next slide. So there are a lot of objectives. I think I presented them last time. Basically, unidirectional is great because of REST-conf, COMI, and it is basically used for constrained node environments. And it will be able to be used with loss of connectivity. So you can basically create audit logs of the attestation, this is the evidence, and then transfer it later. Next slide. We're introducing a third party for this because these timestamp tokens have to come from somewhere. They are provided by the trusted by a timestamp authority. There's an RFC for that. I forgot to put the number in, but Google it. So the TUDA protocol has a nested sync protocol, but is basically encapsulating the timestamp token into 2 other timestamps, and now it comes that are provided by a hardware root of trust. We're calling that ROT. So in essence, TUDA is a RAT based on hardware ROT. The TSA is required to create this evidence in basically every scenario. So every thing that would create a secure audit file, audit log, or something that happened in the past and you want to prove it really happened requires a TSA. This is not unique to TUDA. We're just making use of it in the terms in the scope of attestation. Next slide. So we had a lot of feedback for this already. Coming in from a lot of participants of I2NSF, I got some of the more, past slide. Previous slide, please, because this is the second question. So Why using TUDA if it uses a sync protocol and makes things more complex? Yeah, well, that was the very first question, but I think I somehow answered it. There are, please look at RFC 4949, the Bell-LaPadula and the BIBA model. Both are specific models that focus on confidentiality and integrity if you change trust level zones. Talking about a nuclear plant and critical infrastructure, that's kind of important to attest the things inside without being able to compromise them from the outside. Just read that up. It's kind of obvious. Then second slide, please. A question? I'm running through these items because of time. So which environments would benefit from the more complex solutions? So we have a lot of IoT stuff going on in the IETF space, and most of it is CoAP. CoAP is RESTful. There is no state. So you cannot facilitate a challenge response protocol without state on the server side. Also, there is the idea of aggregating a lot of requests for attestations with one aggregated nonce. This is an idea that was published by our lead author actually 10 years ago, and it does not address the RESTful CoAP IoT problem, we think. Next slide, sorry. So doesn't the TSA introduce new attack vectors? Yeah, it would. Of course, as with every other component that is required to create security, it would create another service, in fact, that is, of course, an attack vector. For example, there's probably an I2NSF component that takes charge of the security of the service of the software itself, or, for example, prevents re-signing of anything you create into an I2NSF domain. So there will be security functions, of course, that create security into the I2NSF domain, and the TSA will be just another function like this. Next slide. So yeah, we can broadcast, of course. We can beacon it out unsolicited, and they are not encrypted. So if we just beacon those out, yeah, those would compromise privacy, but that is not a problem unique to TUDA. That is a problem that we chose to do it with the broadcast, and please just use a secure transport for that. So next slide. Next question was, does the stateless nature support incremental attestations? And most certainly it does. It is basically the one point of creating partial audit logs that you can create as measurements accompanied with the evidence. So the MIP shows you a very good way how to do this via SNMP. Yang can do it way more easily, but we started with the most complicated thing we can find, and that was SNMP. So last question is after this, I think. So how would, and up again. And up again, please. So how would hardware root of trust and virtualized environments work? Because a virtual machine does not have hardware. This is called a virtual hardware root of trust. A lot of SDOs are working hard on this for like, I know, 6 years. And I think at least 2 SDOs that are not the IETF have solutions for those. Unfortunately, they do not do public review on a regular basis, but I know for certain that they will do public review, that one of them will do public review very soon. So this is not a TUDA specific, but an attestation specific problem.
Hi, Kathleen Moriarty, SecAD. Last meeting, you approached me about doing this work since it's across multiple groups and another mailing list. I don't remember ever seeing a request.
Oh, no, this was about the terminology for attestation, because everybody thinks attestation is something else or doesn't know what attestation is at all. So it is about talking about the right things there. There is a draft. It's an individual draft with General Electrics and ARM. It is posted. I can post this draft to the I2NSF list if you want.
I was asking about the separate mailing list.
The separate mailing list requires that we need a draft, you said. We can talk about, we cannot just start a list. Please create drafts first for that list. That is the first draft. It was your recommendation.
All right, I still haven't seen the request for the list.
No, yeah, because there was that we released a draft 2 weeks ago. So
okay,
you have to compose a request. Also, there will be a attestation, event terminology draft also. Thank you.
Okay, thank you, and we're done. Apologies for our appalling time management at this end.
I have to speak so fast. And I'm speaking fast already. This is
He asked for a mailing
for
list.
this work. So this will go on to a different work group.